I'd like now to introduce my next speaker, Erik Ubels, who is the founder of MetisReal, which supports stakeholders in the smart building space. And Erik is about as close to a rock star as we have in the smart building area. So I will tell you this, that at most conferences, he's one of the most favored speakers because he truly understands the granular nature of the real-life application of the technology. And he has so much to offer, I'm ashamed to squeeze him into 20 minutes here, but he's going to have to do his best, but you can talk to him afterwards. Erik, please come on up.
Can you hear me now? Yeah, thank you. Right, so every time I get an introduction at these kind of events, especially from Bob, he raises the bar. I'm not a rock singer, I can't sing, so I won't do that for you. I'm trying to explain in 20 minutes how to get to a smart building or state-of-the-art smart building. We'll try to do that in 20 minutes. Let me see if this moves forward. Yeah. So I got a couple of things I want to share with you today. First of all, we need to agree on what a smart building is, or at least you have to understand what I think is a smart building. So a definition, then about the deep digital integration, then the AI-driven optimization and learning in a building, and how to get there, and obviously with a conclusion. So first of all, in 2020, when I started to become self-employed after working for Deloitte, building the Edge building, and then work for Edge Technologies, which is quite famous for building smart buildings. We worked on a blueprint there for smart buildings, and that is basically what they are using to build a lot of smart buildings throughout the Netherlands and in the UK now, as well as in the United States. Pretty successful smart building company. And we built a platform, a software platform. We already built a software platform at Deloitte at that time, but that was never ever meant for commercial purposes. We did not even realize it. So Nicholas said there was a mastermind behind. There was nothing mastermind behind it. I just did it with my people, and I was convinced when Deloitte board asked me to build a building, I never done a building, let alone a smart building. But I was running the IT for Deloitte on a global scale, and I knew one thing. The credit I got from IT, with all the people working with me to do that, was based on one thing. We knew exactly what was going on with IT. Everything in the world at Deloitte, we knew what people are doing, how are they using it, where are they using it, how many times, what are systems doing, what are our data centers doing. And the only thing I thought about is, okay, if we get the building in operation, I need the data. And if I have the data, I will figure out what to do with it, and then we can optimize and run the building and do whatever we want. So the number one question to every single vendor was, how do I get the data from your system? Half of the systems at that time did not have an API or a connection. They were just like standalone pieces of technology. Lucky enough, that has changed a lot. So a smart building, to me, is a high performer. Yeah, this was my 2020 statement. I already thought, and I spoke to Nicholas earlier this week, I thought it was already quite broad or wide. But I thought I have to redo that 5 years later. So a smart building for me now is a high-performing, human-centric, digitally enabled asset designed from the outset to optimize sustainability, resilience, and experience across its entire life cycle. And this is very fundamental to me. We build new buildings, and we know we're going to tear them down. That can take like 40, 50, 60 years, whatever, but we will do that. So it's also about material choices, circularity on the construction, the concrete, the wood, the glazing, the copper, whatever you use in the building, you have to know where does it come from, who manufactured it, what kind of materials are in that stuff, and how do I get and bring that back? Because I'm convinced that other than in the past, buildings, and especially commercial office buildings and these kind of buildings, will not last for 100 years anymore. Because we change, society changes, our needs are changing, so we need to get smarter. There's a huge responsibility for the real estate industry because it's one of the largest industries in the world, And what most people don't realize, but according to the World Economic Forum, they lose a little bit of their credit, I think, but okay. The World Economic Forum basically said that by 2050, 68% of what we as humankind need to build or to live in, to school in, to whatever we do in, still needs to be built. Can you imagine that? There's more than all the stuff we already have in the world. That's because people are still moving to cities, and people, now, you can argue whether the population is growing, but there's still a huge demand. So, and it's a hugely polluting industry. About 40% of the world's carbon CO2 output comes from buildings. So anyway, that's a pretty wide definition, and I totally with Nicholas, I'm about this wide, holistic view on what a building is. It's the build, the materials, the construction, how we got there, how we use the building, how it's performing from an energy perspective or whatever, and how it treats the people in the building, but eventually also how we tear it down and reuse that material. I have to get used to it, I can see it over there. So, deep digital integration. That's the fundamental piece for me of how to get to a smart, state-of-the-art building. And deep integration, this picture is just a metaphor because it talks about the IT part of it. But I mean, as I said a moment ago, in everything. So it's not only how you connect all the devices in the building, but also how you deal with all the other things happening in the building. But let's focus a little bit on, this is called Transform IT for a reason, so let's talk about IT a little bit. This is already still hard. So in this picture, it looks like we want to connect everything we have in the building to the same network. That's a kind of a metaphor for saying, whatever you buy in the building, the number one question you should ask your vendor, how does it connect? And how do I get the data out of that thing? And I can tell you that's already a difficult question because half of them do not have an answer. Or they don't want to give you the data. So if you start a project and you talk to a chiller manufacturer, air handling, heat pump, whatever it is, and they say, well, yeah, we got data, but it's our data, walk away, next vendor. There's a huge amount of vendors that will give you the data. It's your data. You are buying for whatever you put in the building, so it's your data. So why do I have to have a license and pay for the data, which was mine anyway? Happy to share it with the vendor because the vendor will need the data to use some AI algorithm to optimize the heat pump or the elevator. That's fine, that's their job. But you should have the data without any argument. What I was trying to show in this picture, Bob will remember the picture, I was using it in Barcelona, is basically when you build a building, you've got all the stuff that comes with the building. So the power distribution, the HVAC, the elevators, the light, a lot of other stuff. So imagine one of these dots are presenting the stuff that comes with the building. The other stuff is put in by whoever operates the building, the CBREs, the GLLs, or whatever, before they have a tenant in the building. So they want to have a building access system, they probably have a camera security system, they will have some parking barriers, whatever they put in the building to operate the building. That's the other color, whatever color you choose and like. And then you have the tenant that comes in and also puts stuff in there. Maybe like Wi-Fi, maybe coffee machines that are connected to the internet, maybe dispensers in the restroom or whatever, people counting capability, indoor air quality, whatever was not coming with the building, that comes along. So you've got a lot of stuff in the building, and in one way or the other, we want all the data. In a state-of-the-art smart building, we want all the data, period. So don't even get in arguments with vendors about what you need and not need. I want it all. Why? Because you can throw it away afterwards much easier if you don't need it than having an argument again with the same people of what kind of data you want. So check about that when you buy any system. So deep integration starts at the lowest level, and I will come back to that because that's only the connectivity level and getting access to the data. Obviously, we want to have an AI-driven building. And that's across everything we have in the building. So today you can buy heat pumps which have AI in their controller, and it optimizes the heat pump. Nice. It can optimize the elevators. If you have 2 or more elevators, you put them in what is called an elevator bank, and now the elevators knows when you push the button, you press for your destination, so you're not going into the car or the cabinet and then tell you to which floor. You probably recognize this from some buildings, but you put this on the outside on the console, and you're telling to which floor you want to go, and the elevator system figures out what is the best floor or the best ride for the elevator from an energy and speed perspective. So there's a lot of AI going on in buildings. Building management system manufacturers, whether they Schneider or Siemens or Priva in the Netherlands or Souter or Johnson Controls, it really doesn't matter. All of them are doing AI, one more than the other, but it's on the building management system, which is nice, but I don't want it just in the building management system. So an AI-driven building, and to optimize it across everything. So from an energy perspective, with help from the European Union, the Energy Performance Buildings Directive, number 3 and now moving into 4, that changed a lot in the world of smart buildings, because now everybody knows that you have to have a building automation and a control mechanism in your building, at least at a certain level of energy. I can tell you most commercial office spaces already have to have that given their size, and you have to report. So you need to have all of that stuff in place. So you want the data from the energy monitoring and all of that. But to optimize a building across everything, as Nicolas already touched, you want to optimize also based on occupancy. Not only the space you have, so you know how the meeting rooms are being used. And I can tell you one thing, we go into new building projects, and for 3 years, because that's how long it sometimes takes, we have arguments with, the customer. Oh, I need this many amount of sizes, and I need so many rooms, and so many there, and this size, and this, and phone booths. All wrong, all the time. So I'm trying to explain to my customer, let's create rooms that are flexible. You can now buy interior walls that you can change overnight. They're slightly more expensive, but then again, they're much more circular. So if you really think about that, and it's always wrong. The biggest example I had was the headquarters of Unilever in New York we did. It was going on for 3 years. And I can tell you one thing, on Thursday after 12 o'clock, this is the US, and they always make us believe they work harder than we, which is not true, but they talk more and they spend more time in the office, but that doesn't mean they work harder. The interesting thing is, Thursdays after 12, all the people started to move to phone booths, to start chatting with the family, because they are going to travel home. And on Friday, there was nobody there. And we had this huge mistake between the amount of rooms we had in the building and how they were actually used. And then, of course, if you build this in drywall material in a fixed structure, no single person in that company would allow you to say, let's tear out these walls because all the meeting rooms are wrong. So that's why I say, with AI and with data, you can exactly tell how this building is going to be used once it is there, and optimize it if you have the ability to change the drywalls or the walls in between. Why was it getting there? It was actually about using AI to actually use occupancy and how the meeting rooms are being used, how many seats are being used, what area of the building are used. One of the surprises, again, in Unilever was that we figured out of the 5 buildings on that campus, we could close one down completely on Friday. And that's exactly what Unilever did. Do the math. If you can completely close down a whole building on a campus every Friday, that's a lot of money. In Deloitte, I tried to do the same in the Edge building. I did not want to, how do you say that? So you have departments, audit and consulting and tax and all kind of people. And they're all on their own floor. And I said, no, we're not going to do that. You can sit wherever you want, and then we're going to tell you where to sit. People didn't like that. It was our first AI application. We did that together with Microsoft. So you come into the building, and we were telling you, aha, you're a consultant, and you have a meeting on the 3rd floor at 10 o'clock in the morning, so we're going to put you on the 3rd floor. Why? That you're not going on to the 7th floor with the elevator and then back 4 floors to go to the 3rd floor. That saves us money. And then we started telling people, oh, you like a certain temperature and a certain light level, and we know that. And the building obviously has a behavior as well. It always has a cold side and a darker side and a light and a higher temperature. So we're going to tell you exactly where you should sit. Well, I can tell you that doesn't go very well with people, so we had to give up on that. I never have been able to close a floor down because people spread. And if people went to the 7th floor yesterday, I can tell you one thing, they're going to the 7th floor today again. Even though they need to be on the 4th floor an hour later. That's human behavior, and that is something we should not try to do, but we at least give it a try. So we need AI across all of those different systems, not just an individual system. Imagine even how you would work with that. So I need to go to the HVAC solution and to the dashboards of that solution, and then I can see how AI is doing whatever it's doing. That doesn't work. Then I need to go to the elevator thing. So what I really believe, we want data from everything we have, pull that into the AI, not actually pull it in, but use it in the AI platform, and we will use AI across everything in the building, and then, as Nicholas mentioned, we can optimize it across temperature, across light preferences, energy preference, whatever we have, and we can optimize the whole out of it. To get there, we need a kind of... Did the microphone start? Oh no, it's still working. We need a kind of orchestration across all of AI and data. And that's a bit more difficult because there are so many different data formats, there are so many different ways how data is connected, and the biggest challenge every time is, first of all, to get the data out of the different systems, to get it right, to make sure it's correct, it's accurate, and then still people don't know what is it. What does this actually mean? So labeling the data, giving it a name, giving it a definition, put it in a kind of a library so you can look it up, what is actually meant with a kilowatt hour, what is actually meant with degrees Celsius, etc., etc. So you have to be governed about your data, and that means you know where it comes from, what format it is, what is the meaning of the data. Once you got that, you also have to think about cybersecurity, not only on the device levels, but also who has access to what data, at what time, and for what reason. Okay, so that's also important. And then at a higher level, maybe you put it in database management systems. Nowadays, we don't use that many relational database management systems anymore. We use so-called object databases like Cassandra, maybe you heard of those things, or JSON kind of documents. So you can mix all kinds of crazy data in the same database. And you also want to have basically 3 things. Yes, you still want to have a relational database management model for where it makes sense. So if you have very structured data coming out of a heat pump or out of the building management system, it's quite well organized in tables, and tables are linked with each other. So there's nothing wrong with that, we can use that. The business has a whole different view on how they look at the building than a technician, or how it's optimized in a relational database management system. So we want a semantic model. I'm sure you heard about that as well. That's just a different way of looking at the same data, but much more like the way human being would look at data. A database management system would have a street, and would have a zip code, and would have a name, etc., all split up. That's not very useful for us. As a human being, we would like to look at the contact information of a person, the name, the address, etc. So that's what a semantic model do. And then we still want to have a digital twin model, which is different, and I will come back to that. So orchestration about all the data before we can do AI. So how do we get there? Well, again, we start at the lowest level. We connect everything into a single IP backbone. This is constantly argues I have with my customers. And especially if you're banks. Banks are is there anyone working for a bank here? Ooh, the banks are the worst. So they argue again and again and again, we need separate networks for the building and for your corporate IT. And the argument is always security. I can tell you one thing, that's utterly bullshit. Why? Because current network technology from whatever vendor you buy, even the cheapest you can get, allows you on the same cable to completely separate that communication. Initially with so-called VLANs, that means the camera data only talks to camera data, never ever talks to your Wi-Fi. Wi-Fi is separated from your camera system, but now you have VLANs, you have so-called software-defined networks, etc., etc. There is no way that data will ever come across with each other. Okay? The number one argument is security, and then the IT people tell me, we do not trust the building people with their network. And the building people will tell, we do not trust the IT people. Aha, that's interesting. Well, IT people, if you do not trust the building guys, I would make sure that their network is yours. So you can apply all the security stuff you want, so it is secure. And the other way around, if I'm in a meeting with the building guys, I say, well, if that's the case, I want to make sure it's one, because that at least, my argument is, from a technical, security, cyber perspective, there's no reason to split it. There is a good reason to have one converged network. You save on copper, which we should do for the planet. You save on fiber, which we should do for the planet. You save on switches, Ethernet switches and connectivity, which we should do for the planet. By the way, if you build two networks, all of them will have more capacity than is actually necessary. So if we make one network out of it, we will save on equipment, on energy, because all of that equipment is using energy all the time. Again, for the planet. If it's not for cost, we do it for the planet, on the raw materials. The Edge building in Amsterdam has 11 kilograms of copper per square meter. At that time, it was the lowest in Europe, for so far we knew. But typically, there were 27 to 40 kilograms of copper per square meter in a large building. We went down to 11. We are now doing a building in Den Bosch, in the Netherlands, which is down to 7 kilograms of copper. So there's a reason why we are doing this. Security is not a reason to have two separate networks. We want to connect everything, we want to have every data, we want to have access to it, and we should have it free. That's where it starts. Then, obviously, we need a platform. And there's a lot of people who sell you platforms, whether it's Planon, the facility management, Fred is working on that kind of stuff. There are many others out there. The building management people tell you, the BMS manufacturers try to sell you a platform. Then we have the Space Wells here out of Belgium who try to sell you a platform. The problem is, none of these platforms, whatever we tried in the last 12, 13 years, gives you all the things you want. They simply do not exist. So in Barcelona, Bob will remember, I made this argument, I did a presentation, and said, free your data. Let's use the technology we can have today. Today there are so-called software as a service data AI platforms. These platforms are so damn good, and I can honestly tell you they are not only surprisingly good, every time we demonstrate this to customers, what? How is this possible? What does it mean, such a platform? That basically means that in the past, it's not very good visible, in the past I've done 7 of these platforms. So in the Netherlands there are 7 platforms you can license from whoever built it, and I was like the architect behind it, and I used platform as a service technology. That means out of the cloud we were taking a huge amount of services, bring them together, and like Lego, make them work on a smart building, and then we could get the data out and we can apply AI and do Power BIs and whatever with it. But it's hard. You need to understand all those different services. A single building requires at least 50 services out of a cloud platform environment. And people say, how do you come up with 50? Well, first of all, we need to do some user provisioning. We need to create a user, agree? Your name, your email name, your password. Once you have that, we need to be able to allow you to have two-factor authentication. That's another service. Once we have that, we have to tell you which are you allowed to do. What are you, so you get into the platform, but what are you allowed to do? That's another one. We need databases. We need object databases. We need dashboarding capability. We need applications to be run to do smart things. So I'm not overreacting if I say it needs 50 different services. But so far, we had to put them together ourselves. A lot of effort, a lot of money. Nowadays, you can go to, I took Microsoft as an example, you can go to Microsoft Power BI. Who has Microsoft Power BI? Be honest. Okay. 89% market share in the world. That means a lot of people have it. And if you don't have it today, you will get it because Microsoft is pushing it, and let's not go there whether that's fair or not, but that's what they do. So there's a button in the admin menu that says switch on something which is called Fabric. What happens in 2 minutes? You get a message back from them. In 2 minutes, they generate all of this crap for you in 2 minutes. Honestly, I do this live with executive teams, and I say, while I'm talking to you, I will do this. So I bring a whole box of sensors with me in the room, put the sensors, all wireless, in the room. I'm asking them if I'm allowed to use a wall outlet. Why? Because I need a gateway to communicate to the cloud. And then I build this stuff. And then on purpose, at the end of my presentation, I'm not talking about it. There's always a smart guy saying, hey, Erik, you were doing all this stuff. What's the reason? Oh, I forgot about this. And then I show them that I have the data, I have the AI, I can talk to it, I have the dashboards, and I not made one piece of it myself. It was completely automatically generated. What I'm trying to say with that is start thinking about that you should not be worried about all of this stuff we IT people were doing in the last 10 years. It's no longer necessary. Okay? One, and this is my final slide, and Bob knows that because it's always my final slide, is digital twin. For 10 years, I've been advocating digital twin. And every time I have to tell people, what you said is not digital twin, in my opinion. We can have a chat about that. So, a beautiful 3D model from, let's say, Autodesk or whatever other platform. On trade shows, you see people demonstrating this. They got this building in front of them, then they pick the mouse, and then they can turn around the building, upside down, blah, blah, can walk through the building, see all kinds of parameters, temperature, occupancy. That has nothing to do with a digital twin. That is just stuff coming from a database put on top of this 3D model. A real digital twin uses, I think you refer to it, uses an ontology. That basically means it's a modeled environment. That means that the building is obviously modeled in a digital twin, but even a city. I've done now cruise ships, hospitals in the US, oil rigs, and what is the difference between that picture, which is beautiful, don't get me wrong, but in a digital environment, we model the building. That means that model knows exactly how the building looks like from a physical perspective. So there is a building, there's a size, there's a location, it has floors, it has a height. On the floors there are areas, there are rooms, it has elevators, and all these things are connected. And not only are they connected, they know what they can do. So they are much beyond just putting data in. I have one example of that. Temperature and humidity are connected to each other. 99% of the people with a digital twin will pull up those two numbers, put them on a picture, but there is still no relationship. But I can tell you, and you remember from school, I hope, that temperature changes, humidity changes, and the other way around. There is a law, a physics law, that says this is the kind of relation. I can tell you, if you have a meeting room in a building, and it's meant for 6 people, and you put people in that room, then the temperature will change. Because that's what we do with our human body. And a difference between 2 or 5 or 8 people in the room. Humidity will change. CO2 level will change, even if we put in clean air. So we need an ontology to make a real digital twin. And that's maybe the most important thing I want you to take away from this today. If you start doing smart buildings and you want to do it right, you have to have a digital twin. And hopefully you live in a city where they're building digital twins. Sweden is pretty good at it. They started this whole thing. Singapore has a digital twin for the building. So you can interact. And the nice thing is, you can do this without ever building the building, which means you can run the building before you ever build it. You can even simulate the building. You can even simulate the city. So that's my final slide. Thank you for your attention.